A heterogeneous processor is one that combines different kinds of processors within a single chip. A good example of that is today's APU, a processor that combines CPU processors with GPU graphics processors. A heterogeneous processors may seem complex and mysterious, but how they operate is really quite simple. CPUs are optimized for processing serial workloads, executing tasks as a sequential order. In contrast, GPUs excel at processing parallel workload, executing multiple tasks simultaneously. Let's show you an example of how each type of processor would handle a task like, say, making 10 sandwiches. Let's assume making one sandwich requires starting with one slice of bread, followed by a slice of cheese and perhaps a piece of meat, and finishing with a second slice of bread. So a traditional serial processing CPU would make 10 sandwiches by repeating the sequence 10 times. Each time, starting with a slice of bread, adding cheese, adding meat, and finishing with a second slice of bread, and moving on to the next sandwich. But all this could be done in parallel, more quickly and more efficiently. Instead of making one sandwich at a time, we could start with 10 slices of bread, adding 10 slices of cheese, and then 10 slices of meat, and then 10 more slices of bread to finish all the sandwiches at the same time. Like choosing the right sandwich making method for the number of sandwiches to be made, modern APU processors select the most efficient type of processors to work on a given computing task. Based on how many times that task will be repeated, the APU will select a serial processing CPU for certain computing tasks, and then choose a parallel processing GPU for others. But the most important thing is that both types of processors must work together as a team. This is made possible through a revolutionary APU processor architecture called Heterogeneous System Architecture, or HSA, that enables the CPU and GPU to achieve optimal performance and efficiency by working together in harmony as equal partners.